So in this video, we're going to be looking at cast in place board piles. So we will not be looking at precast piles as they are a little bit different in detailing, especially when they have strands in them. But we will just focus on the board piles for this video. What you see in front of you is 3 board piles, and I have deliberately modeled them a little bit shorter so we just have a little bit more detail on the screen, and we have quite a fat triangular pile cap on top of them that we will detail in the follow-up video from this one. So let's just discuss 3 methods of detailing this. Two being, or the first being a custom component, the second one using rebar groups and single bars, and the third one, I just want to actually, rather than showing a method, just highlight why I would not use rebar sets on this, because rebar sets and circular columns, there's a problem with the ligatures in the lapping, but I'll highlight it when we get there. So let's start by the first pile, and what I want to do is use the custom component. So also, just before we get started, as you can see, these are all cast in place elements. So if I highlight them and we go to the property pane, we'll see that the cast unit definition is a cast in place. But for the sake of this video, although I know we're working with cast in place, I'm just going to temporarily change it to precast. And the reason I'm doing that is if I accept that and click away, the precast is shown with nice accented edges, so it shows up really nice in videos. You do have to remember that afterwards to change it back to cast in place to have your model more accurate. But for this illustration, I'm just going to mark them as precast, and we will then have a better view. So I'm going to go into transparency mode. And the first thing I'm going to do is head over to our Applications and Components tab. And in the search, I'm just going to start typing in reinforcement. And once I get all the reinforcement components on the catalog listed, I can go to round column and click it, go over and select my concrete element I want to reinforce. Now, by default, if you just double click on it, Tekla will read the standard default file with the standard settings that is applicable to your specific environment. In our case, it is the Australasian environment, and we will start by tweaking a few of these figures to get that looking more like a pile instead of a column. Okay, so I think the first thing we want to do is if I go Control P to just get it in plan mode, ortho mode plan. The first thing we want to do is just address the cover. So maybe before we address the cover, let's just address the number of bars and the diameter of the bar. So at the moment, we've got 6 bars. So let's just beef that up to, say, for instance, 8 bars. And instead of showing an N20 with a 60, let's show an N24. Okay, and then for the class, I'm going to use 2, which is the red bar. And I think that is okay for now. So if I say modify, you can see how it's changed that to red bars and it's increased the number. I also want to do the same for the stirrups. Now, on the stirrup tab, we've got 2 tabs here. The one deals with the dimensional properties and the other one deals with the attributes in terms of what material or bar type we can use. Now, I want to change them all to an N12 ligature or tie. In Australia, we, especially in infrastructure, they tend to refer to stirrups or ties as ligatures, and I think in some of the UK areas as well. So we will just change them all to tie. Now, the reason why I'm clicking on the catalog and not just typing a 12 in there is I never know with these how the component reads the radius. So if we click on here and we look at the 12 tie, it's got a 24, and the 12 May has got a 30 bent radius. So it's not clear because there's no facility to type it in here. So I just select them to make absolutely sure that I get the right one. Then also what I want to do is I just want to change the class to a 5 to get like a light blue cyan type of color. Then if I say modify, you can see how we now upgraded the stirrup and change the color for it. Okay, so now that we've got that, we can start looking at the cover. So the first cover I want to address is the cover on the ligature itself, or the stirrup, and currently it's shown as 40. Now, if we deal with piles sitting in ground, especially if it's an aggressive sort of material, you would like more cover, and a good specification would be 75. It's a very common sort of cover. Now if I click, if I type in 75, then I say modify, you can see how the cover increases here and it pulls all the reinforcement in. So that takes care of the sort of perimeter in the radius. If we go back, if we go now and draw a section right on the center line of that, we can say, I've got a shortcut C2, but you can also get it by going to View, New View, use 2 points, and we can just find the center there, and also just come across, make sure that you snap into the x-axis, and if we go Control P, we get an elevation on that, and if we go Control 2, we can see a transparency of it. Now what I want to address is, we've addressed the side cover here. What we need to address is the bottom cover. Now if I select the component down the bottom here, at the moment you can see there's minus 25. Now it's minus because a positive would be an extension. So if we, for instance, just type in 200 there and say modify, you'll see that it extends it beyond the concrete by 200. That's not what we want. What we want is minus 75 to deal with cover. Now the cover for the main bars and the ligatures in this component is dealt with differently. So we'll first wrap up the main bars. So we've dealt with the cover at the bottom. Now at the top, it looks like a joggle bar, a J bar, but we want straight bars because they actually end just in the pile cap. So what we can do is first, or the extension from the top of the concrete to the top of the bar. In the case of a 24, I think 1,200 1.2 meters is good. So we say modify, so that lifts that up. Now in terms of getting rid of the crank here, what we can do is, the crank has got 2 dimensions. The crank start below the concrete and the crank end above the concrete. So below the concrete we can make that 0. That will pull the crank up to the top of the concrete. And the top crank we can just ignore, and the offset we can make 0. And say modify. That will give us then a straight bar projecting 1.2 meters above. Now that takes care of the main bar reinforcement. What we need to do now is just address the rest of the stirrups. So on the stirrups, we've got on the stirrups we've got 2 tabs. The one tab being dimensional properties in terms of spacing and cover. The other one being, as I said before, the material, what type of rebar we're using. So in terms of the stirrup, what we've got, let's start at the bottom. At the moment, you can see we're quite low there. We're not even covering the 75 to the main bar. It's because we're specifying down the bottom here 50. So what I want to do is I want to at least address the 75 plus another 25. So there's a piece, there's a bit of bar left to weld the ligature on, because these pile cages are prefixed. You know, they're made up before they get dropped into the hole. So we'll make that 100 millimeters, and if I go modify, you see how that picks up. So there's still weld room there. And then if we go to the top of it, so normally with piles, they project about 50 millimeters into the pile cap here. So we need that 50 millimeters plus another 50 down. So at the top, we'll change that 50 also to 100 and say modify. So that will give us, you know, the correct cover on top. So that deals with the cover. So we've dealt with all the cover. The second thing we need to do regarding the ligatures is address the spacing. Now, at this point in time, we've got a lapping stirrup, which in terms of a pile would probably imply that it could be a welded ligature. If it's not, you'll probably find that an engineer will specify a hook around here. Now, one of the limitations of this component is, if you look at the stirrup shape type, we can have the round default one, which is the one you see in view now. We could have one that sort of wraps around all the main bars. If I just modify that, you'll see what I mean. So if you add 10 main bars, it will actually have a kink on every bar. It's not something I have seen in practice before. I'm not quite sure if it's used in Europe or other parts of the world, but certainly in Australia, I've not seen that practice before. And then the last one is the same as the second one, except that it doesn't have the hooks. It's just a lap. So we really limited to the stirrup shape of the round. The only limitation here is we can address the length and the angle of the lap, but we cannot address the ear, so it's going to have to be a welded bar. In terms of the ligatures, I think we'll live with this one for now. what I want to do is address the main pitch spacing. Now for ligatures in piles, 150 is very common, and normally with these at the bottom, your first and your fifth zone, they normally half the spacing of the main. So if your main is 150, these are normally 75. It is not an absolute, it's just sort of a detailing norm, I would say. And then also the number of that's specified. Now 3 is a pretty common value for the closely spaced ligatures at the bottom. So you have 3 very closely spaced at 75, then you have the rest of them spaced at 150, and on top you've got 3 spaced at 75. And that pretty much deals with that type of configuration of pile. Now, what I want to do is I just apply that so that it's sort of the settings are temporarily saved, okay? And then I'll re-engage that component again, and I'll pick the second pile. Now in this pile, it's going to use the same values as with this one. So at the moment, they're looking exactly the same. But what I want to do in this one is I want to engage it or activate it by double clicking on it. And then I want to change the stirrup to a spiral. Now, in terms of the spiral, if I say modify, in terms of the spiral, again, it's going to give you your 3 close loops and then your normal pitch. But when you have a spiral like this, normally what they have is they have 3 very close, close loops. So this bar is a 12 millimeter. That's the nominal diameter, but the actual diameter is 14 because of the ribs on the deformed bar. So it's 14 millimeters. So from center to center, it will be 14 millimeters. So if we make that 14 at the top, and we make this 14 at the bottom, and we say modify, what happens then is you get 3 rings on top, spaced exactly on top of each other. Then you get your normal spiral, which is pitched at 150, and then at the top you end off with your 3 closely links too. This is very common practice in piles to do that. I think there is also this option if you click on the spiral to have separate spirals. So for every zone you've got a spiral. So if I click on that one and say modify, what we do, we end up with a loose spiral. If I just flick around here, we've got a loose spiral at the bottom, we've got another one intermediate, and we've got one at top because we've only defined 3 zones here. Now, I've not seen that, and I would imagine that will be applicable where, where the spiral gets too long. They actually don't have a long enough roll for it. But generally, when you're using 12 and 16 millimeter bars, they are on rolls, and the rolls are, 70, 80, 100, 120 meters long. So it's quite easy to roll a long spiral off it. So I would also always go for one continuous spiral top to end. Oh, I think I didn't double click it. Let me just double click it. Go back to the spirals and change it to 1. So that pretty much takes care of the component part of it. Now, I'll just close this view because we don't need it anymore. And if we go back to our rendered view from the top, we now have the 2 different types. The one using loose ligatures that are welded up as a cage. The other one utilizes a spiral with closed ends. Now, the last method really that I want to do is the manual, the using of the rebar groups and single bar. So for that, again, I'm going to go C2 and create a section along the center of this pile. And then also on the view, I'm just going to make sure that I only see that pile by specifying 500 modify. Okay, so I'll only see that pile, and I'll put it on elevation, and I'll make it transparent. I'll go back to the previous one so I can see it from the top. So because this is Control P, it's a ortho view, and it's viewed on the plane. I'll be working at the bottom of this pile. So if we go to Rebar, we head over to Rebar Group, and we head over to the Circular Group. We can then go to our Property tab and make sure that we load our defaults, just in case we've got dodgy settings here, and then we can start tweaking. So first thing is I'm going to go to the catalog and select a 12 tie or stirrup. I'm going to change the class to a 5 so it ties in with the others. I'll leave it normal for now, and I think I'll leave all the others so we can see how we change them. And what I'm going to do is I'm going to click the part to reinforce. Down the bottom it says part to reinforce. I'll click the part, and then it says pick 3 points. So what I'll do is I'll pick this point, I'll pick the top point, and I'll pick that point. Now that is to define, you need 3 points to define a circle, and that's enough. So now Tekla knows what the circle looks like. And now it's asking me pick 2 points to indicate the range. So if I click this one, that will show the bottom of the pile. So if I go into 3D mode, you'll see that it's defined the bottom of the pile. So if I then, let me just get a proper view here. If I then go up, make sure that the blue axis is engaged. So you make sure you, until it snaps to a point, and you can also look at the dimension, it says 3.5. And I click that, we will get the stirrups as loose stirrups with a slight overlap there. Now if I click on that and look at the property pane, the first thing we want to address again, if I go from the top, look at the top, is the cover. So it ties in with these. So at the moment, if you look at that, that cover would be defined by the on plane setting. At the moment, it's 25. So what we need there is 75. If I say modify, that will pull it back. And the second thing we want to address is the on or the from plane settings, and that's the bottom and the top. Now, in the property pane, it says from plane 25. Now, this can also be a list. In other words, you could have, say, for instance, 75 at the bottom, and you could have 200 at the top. If you then say modify, you'll see 75 at the bottom. And if we scroll up to the top, you'll see there's a 200 at the top. But in this case, we want 100 millimeters to tie in with the others on both sides. So what we'll do is we'll replace all of those with 100 millimeters, modify, and it will be the same as the others. Now, at the moment, what we've got is we've got, and I'll just drag this property pane open over a little bit. At the moment, the creation method is by exact spacing values with flexible first and start and last spaces. So what I'm going to do is I'm going to change that to target spacing, and I'm going to make the pitch or the spacing, you know, in piles we talk about pitch, but I'm going to make it 150 to tie in with the others. And once I say modify, I get a general spacing here, exact spacing value of 22 at 149.36. Now that's good enough for what we want to do now, because we want to end up with the same sort of result as that, or in this case, this one. So what we're going to do there is I am going to change the creation method back to exact spacing. And then in here, I'm going to go home and I'm going to start typing. I need, now we're talking spaces here, and 2 spaces defines 3 bars. So if I go 2 times, and the amount I want to add it is, as you can look at this ligature, if I just zoom in here, it's double already. So that's 14 plus 14 is 28. So we need at least 28 spacing there. So it's 28 and leave a space. Then we'll have the general, and I'll change that 149 to 150. So it's round. And then I'll end off with 2 times 28 again. Now, if I say that and I say modify, you can see we have 2 ligatures exactly on top of each other, not clashing. Then we have the general 150 spacing all the way to the top. And then on top, we've got 2 again, or 3 bars spaced at 28 exactly. Now, if we go to the other view and we just make sure we're on Control P and we look at it in elevation, you can see it's sticking out the top. So all we need to do in this regard is change the 22 to 21, and we can say modify, and then we end up with a good looking spacing there for ligatures. Now, in the case of spiral, should you want to change this to a spiral to match what we did with the component, all you have to do is in the rebar group type, we can pick spiral. And then what we need to do is we also need to address this, because if I just leave the exact spacing, because each spiral or each stirrup at the moment is lapping with each other, but in the case of a spiral, they don't. So what we need to do is just address that 28 and make that 14 again, and double click in that one and 14 again and say modify. That will sort out that. So we get 3 rings at the bottom perfectly. Then we have our spiral at pitch at 150, and then at the top we've got our 2 again. Now you can see this one, if I go Control P, we've got a bit of space at the top, so maybe we can then reinitiate the 22 again and just see where it gets. So it gets too high, so we're going to pretty much be limited with 21. Now the reason why I leave it at a 150 rather than trying to break it up into a 151 or 152 to get it exact is that it makes drawings hard. You know, if you have silly dimensions there. When you start putting annotations on drawings, especially with rebar spacing, and you know your spacing values have silly numbers in it, it makes it hard. And in terms of cover, you know, it's always defined as a minimum, not a maximum. So if the engineer is calling for 75 and you end up with 80, that's okay, as long as you don't end up with less than 75. So in this case, that will be okay. If you want to go back to the normal, again, we can just flick it over to normal, change the 14 to 28, change this 14 to 28, beg your pardon, 28, and then say modify, and we end up with the previous result again very easily. Now, there is another thing. We need to look at the cover. So on the cover here, at the moment you can see our start and end cover. So from the start, this little yellow handle here defines the start of the bar. You can see it starts with a 0 and it goes around, then it extends beyond at the end by 150 mils. Now what we want is we want to use the start as a center, start the lap sort of split over that handle. So if for a 12 millimeter bar we require a 450 lap, so what we can do is start at the start define minus 225, which is half of 450, and at the end minus 225. And if we then say modify, you can see that if you look at the midpoint there, it's now started 225 before and it's ended 225 after our start point of our bar. And that's pretty much what we will have. And the other thing that we can do, and the reason why I switched back from spiral to this, is to show that we can then introduce a hook type on this, which we can't do in the component. And if I change that to 180 degrees, it adds a hook. And if we go to the previous view, let me just flick over to that view. There we go, Control P. If we then look at it from the top, we can see we've got the ears, 180 degree ears on that. So, okay, the only thing we need to do now is to actually do the radial bars, the main bar. So if we flick back to our elevation view, what I'm going to do is head over to the Rebar menu tab and then go to, on the ribbon, go to single bar. And in the properties, it will load the default properties. I am going to change the bar grade to a 24 main as per the previous. I'm going to change the class to a 2, and then I'll leave all the others as is so we can see how we tweak them. And then Tekla is asking for the part. We'll click on the pile, and then we're going to start at this corner. And just make sure that you zoom in enough so you actually, it's gonna click, because you're in an ortho mode, it's gonna click on the plane of the, we just click it of the grid, which is right in the center. And then if we take it up, we can then, or let's keep it Control P so we can still see it. We can then go up, and instead of clicking on that, we can hold in the Control key and then click. That will give us a red there, which implies temporary snap. And then we can just drag it up, make sure that it's blue, and say we want to extend another 1200 millimeters. So that will give us the top there. Now we can hit our middle mouse button. Now you can see from that the bar is actually outside the column, and this is best viewed in plan. So if we flick over to the other one, we can see where our bar is. Our bar is over there. Now we've got to address the on plane and from plane settings. Now this offset looks like it's a rotation. This offset here, the vertical dimension, is the from plane setting. So if we just make that 0, there is no offset. That will sort of bring the bar back in line. Now, in terms of the cover, it's got a 25 cover, which is the outside. If I drew this bar from the top down, that would have been on the inside. It's a directional thing. But you can always just add a minus, then it will flick it to the other side. But 25 is not enough. We need to put the bar here. And the way we work that out is we know we've got 75 covered to the main bar, and we know the main, or the stirrup rather, and we know the stirrup is 14. That gives us 89. And let's have a 1 millimeter grace. So we need 90 millimeters, and we need it as a negative. So if we go minus 90 here and we say modify, that bar will then be placed right on the inside that without, there's like 1 millimeter spare there. And that pretty much takes care of the main bar. So what we need to do is just radial it. So what I'm going to do here is I'm going to click on the reinforcement column, or not the reinforcement column, I'm going to click on the column. And the reason why I'm going to click on the column is to get the grip. Because when I use a tool to radiate, to radial, to array this thing as a radial, I need to specify the origin point, and I would not have that if I if I didn't click the column. So now that grip is lit up. So now I can head over to our Applications Components tab again, and instead of having reinforcement, I'll clear that. I'll start typing in array, and you'll see we've got our radial array. I'll click on it. And now down the bottom, it says pick the objects to be copied. Now, although the column is highlighted, it will not recognize it as part of the column, copied columns. I'm going to click on the reinforcing bar. And once I've selected it, I can middle mouse to accept it. Now the component's asking pick the origin, and now I can snap to that. If I didn't select the column, I wouldn't have been able to snap to that. So if I click on that, it's now asking for an X direction. So I can click that outside. Now it's asking for a Y direction. I'll click that outside. And there it is. It's copied another bar, one of it. Now, if we double click on this macro and we look at what the components actually got by default, which is the standard, it says, I want one extra at 45 degrees. So in our case, we've got 8 bars, of which one is the master. So we need an additional 7 at 45 degrees. Why 45 degrees? Because 360 divided by 8 is 45. And we say modify. You can then see we get all our reinforcements copied around. Now, the advantage of using the radial array tool is that if I click on this bar and I head over to the properties and I just change the, say for instance, I'll change the main bar to a green color, modify, it automatically also updates the column. And if I change the size of the bar, it will update. If you clicked on this bar and said right click, copy special, rotate, you can also do it with this, but they'll all be individual bars. So if something changes, you have to change all of them. So in this regard, when you work with reinforcement and there's numerous ones of them, it's better to use a component to do that for you. It's less editing. Now, the obvious thing that's come about now is that these ears of the ligatures are now clashing with our main bar. So if we click on that stirrup again, and we go down to the start and the end value, now instead of having your minimum lap, which is a minimum 450, we can just increase that to 250, which will then give us a total lap of 500. Oh, and then I type 500, 250. And if I say modify, you can then see that the ears fit in very nicely. And we have another pole that looks pretty much identical to the others, but in a manual, a model in a manual way. Now, another method, and I'm just going to copy for this method. I'll just say copy, and I'll copy from there. Say for instance, I drew a circle instead of say copy. Control C. I'll copy this one from there to, let's say, the end of the grid line, or there somewhere. Do not expand. And then what I'll do is I'll just delete the reinforcement. Okay, for this one, what I'm going to do is I'll just want to illustrate a rebar set. So if we go to the Rebar tab and we hover over crossing of the bar, and we make sure that we've got 12/24, that is a tie or a stirrup, and we've got that defined, and we'll just change that to that. If we hover over this side and we click on it, and I'll just accept it as is now, you will see if you look at the start and the end of the bar, it's got this little, you know, like it almost looks like a start of a crank. Now, you could click on the bar and introduce a splitter, and then just go to any edge there and click splitter, and that will fix that problem. You will see then, you know, it laps, but you still, it doesn't lap like a stirrup laps. It laps like a crank bar, and I have not found a way around that. Also, if you introduce an end modifier, and I'll just use the 90 degree at this stage, and I'll hover over this side, you can see that it's not really, although this end is closer to this modifier, it's using the other end. So it's not really very intuitive. It's actually impossible to get a ligature like this defined as a rebar set. I've not managed to use it. So although I always recommend rebar sets as much as I can, I'll do just about anything I can with the rebar sets. In this case, I will not recommend using rebar sets for ligatures. They don't work very well. It's still a tool pretty much under development. It's a very good tool, and it's come a very long way, and I definitely prefer it to any of the other, you know, rebar groups or single bars, purely because it's so intuitive. But this is one place where I found that I struggle to get it to work. As a matter of fact, I can't get it to work. So I think in future versions of Tekla, we're probably going to see that also being addressed, and we'll be able to do ligatures a bit better there. And unless there's a way that I'm not aware of, but at this stage I can't see a way around. I'll just delete that. So with that said, I think that's it for this video. There's not much to piles. It's a very straightforward. They're going to be very much similar in columns, but in the next video we'll address the pile cap. Thank you.